Okay, so here is a practice problem for momentum principle. I made up a question, I printed it out, but you'd see what happened. It printed terribly. I need a new toner. Okay, so I'll read you the question. I'll explain it to you. So here's a car traveling with certain velocity, and then it slows down and turns, so it has new velocity. And so I made up these two velocities, and in this I'm using this as the x, and this up and down is the y, and that's the z. So would that be right? X cross y. Actually, this would be z. I got it backwards. Okay. It doesn't matter. And so it goes from this velocity to this velocity in 3 seconds and has a mass of 1688 kilograms. And the question is, what's the net force, the net average force during this time interval? So we're going to start with the momentum principle. F net is delta P over delta T. So if I can find the change in momentum and divide by the change in time, that will be the net force. So this is going to be equal, the mass doesn't change, so I can actually write this as mass times delta V over delta T, because the momentum is mass times velocity, but the mass is constant, so I factor that out. So let's just find this delta V. So delta V is going to be V2 minus V1. It's always final minus initial. So that's going to be, I can do the components. It's going to be, I'll write it out. It's going to be this velocity, 5.5, minus that one, 10.5, 0 minus 0, and then 11.1 minus negative 22. So it's going to be plus 22. And I can get that as a value. My handy dandy calculator. Yeah, I know I stole that from Blue's Clues, but that's cool. So I'm just going to do 5.5, enter 10.5 minus, so I could have done that in my head, negative 5, 0, and this one I can do in my head too. It's going to be 33.1 meters per second. Okay, so now I can just put in everything at the next time. So F net is going to be equal to the mass, 1688 kilograms, times the velocity, negative, the change in velocity, negative 5033.1 meters per second, divided by the time of 3 seconds. So if I put all this in, I'm going to have this times negative 5 divided by 3. That's going to be my x coordinate. Now I will use my calculator there. So I have negative 5. I already have it in here. 1688 times 3 divided by. And I get negative 2813.3. And then this times 0 divided by 3 is 0. And then 1688 times 33.1 divided by 3 is 18,624.3 newtons. So this is a kilogram meters per second squared is a newton. So that's the final answer for the net force acting on the car during that time interval. You'll notice here that it's moving in the, it slows down in the positive x direction, so, but still moving, so I have to have a backwards pushing force. So I have a negative x component of the net force. Whereas here it's moving in the negative z direction and then the positive z direction. So the net force should be in the positive z direction, and it is indeed in that direction. The end.